Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0135 indicates a malfunction in the AF sensor, Sensor 1, heater circuit of a Honda CRV from 2017 to 2022. This system is vital for controlling the air-fuel mixture by measuring the oxygen content in exhaust gases. The AF sensor, situated in the exhaust system before the catalytic converter, ensures that the vehicle runs efficiently while minimizing emissions. When DTC P0135 is triggered, it suggests the heater of the AF sensor is not functioning properly, which can lead to incorrect readings and inefficient engine performance. Understanding this aspect is crucial in maintaining optimal vehicle operation. The diagnosis of this code often requires the use of a Honda Diagnostic System, HDS, to accurately assess the issue. The AF sensor, Sensor 1, is a critical component in managing engine performance and emission control. Located in the exhaust system before the catalytic converter, this sensor detects the oxygen levels in the exhaust gases, sending vital data to the Engine Control Module, ECM. The heater circuit within the AF sensor is essential for ensuring the sensor reaches optimal operating temperature quickly. If the heater circuit malfunctions, the sensor may take longer to heat up, leading to delayed and inaccurate readings. This can negatively affect the air-fuel mixture, causing the engine to operate inefficiently and potentially increasing emissions. Diagnosing issues with this circuit is essential for maintaining the vehicle's compliance with environmental regulations and ensuring peak performance. Several factors can lead to the triggering of DTC P0135. A faulty AF sensor is a primary suspect, particularly if the internal heater is no longer functional. Open circuit connections, often caused by damaged wiring or corroded terminals, can prevent the heater from receiving the necessary power. Additionally, a blown fuse A11 7.5A, which protects the circuit, may interrupt the operation of the heater circuit. Understanding these potential causes is vital for effective troubleshooting. Each of these conditions can directly impair the sensor's ability to function, thereby affecting overall engine efficiency and emission levels. Addressing these issues promptly can prevent more significant problems down the line. When DTC P0135 is present, a range of symptoms may occur, significantly impacting vehicle performance. Decreased fuel efficiency is often observed as the engine struggles to adapt to incorrect air-fuel ratios due to faulty sensor readings. A rough engine idle may also be apparent, indicating that the engine is not running smoothly due to poor fuel mixture control. Furthermore, there may be increased emissions, leading to potential failures in emissions testing, contributing to environmental hazards. These symptoms serve as practical indicators that the malfunctioning AF sensor heater circuit needs immediate attention to restore engine efficiency and compliance with emission standards. Recognizing and addressing these symptoms can help mitigate more complex issues. The first step in troubleshooting DTC P0135 involves verifying the problem. Initially, turn the vehicle to the on mode. This means ensuring the ignition is activated without starting the engine, allowing systems to power up. Next, utilize the Honda Diagnostic System, HDS, to clear the DTC. This process resets the computer and allows for fresh diagnostics. After clearing, turn the vehicle off completely, then restart the engine. It's crucial to hold the engine speed at 3,000 RPM without load until the radiator fan activates. This step is designed to put the engine under conditions where it might recreate the fault. Finally, once conditions are recreated, use the HDS to check for any pending or confirmed DTCs to determine if P0135 is present again. Consistency in this code can help identify if a persistent problem exists. In the second step of troubleshooting, conduct a thorough DTC check using the Honda Diagnostic System, HDS. This procedure examines for any pending or confirmed trouble codes in addition to P0135. Specifically, pay attention to DTCs P1658 and P1659, which indicate malfunctions related to the Electronic Throttle Control System, ETCS, control relay. If either of these codes is present, it is imperative to follow their respective troubleshooting steps before returning to the P0135 diagnosis. These codes can point toward additional complexities in the vehicle's systems that could be linked to performance issues. If no additional DTCs are confirmed, you can confidently move to the next steps targeting the AF sensor specifically. Step 3 in the troubleshooting process involves a fuse check. First, ensure the vehicle is in the off, lock mode to prevent any electrical accidents during this inspection. Locate fuse number A11, which is a 7.5 amp fuse situated in the underhood fuse and relay box. This fuse is responsible for protecting the AF sensor heater circuit. Once identified, inspect the fuse to determine if it is blown. If the fuse is intact, you can proceed to the next step with confidence. However, if the fuse is blown, it indicates a short circuit in the IGPS LAF wire between the fuse and the AF sensor. This necessitates repairs to the wire and replacement of the blown fuse to restore proper functionality. In this fourth step, the troubleshooting focuses on the internal heater resistance of the AF sensor. Begin by disconnecting the AF sensor's 6P connector, ensuring that the vehicle remains in the off mode for safety. With the connector removed, use a multimeter to measure the resistance across test points 1 and 2 on the sensor side. This measurement must be taken at room temperature to ensure accuracy. The expected resistance range is between 2.8 to 4.5 ohms. If the measurement falls within this range, the heater circuit is functioning correctly, and you can move to the next troubleshooting step. Conversely, if the resistance does not meet these criteria, it indicates a malfunctioning AF sensor, necessitating its replacement to restore proper operation. During the fifth troubleshooting step, the focus shifts to verifying the internal circuit of the AF sensor for continuity. That the vehicle's still in the off mode and the 6P connector from the AF sensor disconnected, this step checks continuity between various test points and the body ground. You will evaluate connections from the sensor to individual test points to ensure proper communication with the engine control module, ECM. Continuity is essential for the operation of the AF sensor's heater circuit. If continuity is found at each point, you can assume the internal wiring is intact. Should you find continuity issues, however, it indicates that the AF sensor itself is defective and needs replacement to resolve the circuit malfunction. In this sixth step, the continuity check is repeated, but with a specific focus on the AF sensor's internal connections to its 6P connector. Again, keep the vehicle in the off mode with the 6P connector disconnected. Check for continuity between different terminals of the AF sensor and the terminal number 3 of the 6P connector. This is crucial for verifying that the signal and power supplied to the AF sensor are functioning as intended. If the continuity test fails, it strongly indicates that the AF sensor is internally damaged or is malfunctioning. Any disruption in continuity can impair the heater circuit's operation, thereby affecting sensor performance and ultimately triggering DTC P0135. Step 7 involves checking for a shorted wire specifically in the AFHT N line. Begin by jumping the SCS service check signal line with the HDS and ensure to wait at least 1 minute to allow the system to stabilize. After this, disconnect the PCM Powertrain Control Module Connector E, which consists of 80 pins. The next step requires checking for continuity between test point 1, pin number 13 on the PCM connector, and body ground. This step is critical to determine if there is a short circuit within the AF-HTN wire leading to the AF sensor. If continuity is found, it indicates an electrical issue requiring repair. If there is no continuity, you can move to the next step in the process. Step 8 focuses on identifying any open wire conditions in the AF-HTN line. This step requires checking continuity between test points 1 and 2, with the vehicle still in the off mode and both the A-sensor 6-pin connector and PCM connector E disconnected. You are looking for a continuous electrical path between the A-sensor and the PCM. If continuity is confirmed, this indicates that the wiring is intact and functioning properly. On the other hand, if no continuity is detected, it suggests an open in the wiring, necessitating repair. Addressing an open circuit is crucial to restoring proper sensor functionality and ensuring accuracy in readings. The final step in the troubleshooting process involves checking the voltage in the IGPS LAF line while the vehicle is in the on mode. Make sure the AF sensor 6P connector is still disconnected and the PCM connector is also disconnected. Measure the voltage between the test points designated for the AF sensor's IGPS LAF line and body ground. If you detect battery voltage, it indicates that the wiring from the AF sensor to fuse A11 through the PCM is operational. Should you not find battery voltage, this suggests a potential fault in the wiring leading to the AF sensor, necessitating repairs to ensure that the heater circuit can receive the necessary power. This last diagnostic step helps confirm whether the harness and connectors are functioning appropriately, completing the troubleshooting process. Once troubleshooting and any necessary repairs are completed, final verification is crucial. Start by confirming that all repairs and replacements of faulty components have been correctly executed. After confirming the integrity of the repairs, it's important to test drive the vehicle under conditions that previously triggered the DTC P0135. This test allows for practical assessment of the repairs to ensure they address the issues effectively. Finally, clear all DTCs using the Honda Diagnostic System HDS once again to ensure that no pending codes remain. After the test drive, recheck for any new trouble codes to confirm successful resolution. This systematic approach ensures that the issue has been fully addressed and that the vehicle is functioning optimally. Preventive maintenance is crucial in ensuring long-term reliability and performance, especially concerning the AF sensor and its heater circuit. Regular inspections of the AF sensor can help detect early signs of wear or malfunction, facilitating timely repairs before major issues arise. Additionally, routinely checking electrical connections for corrosion or looseness can prevent intermittent failures that may cause DTCs. Monitoring the integrity of the fuse protecting the heater circuit is also essential. Keeping an eye on these components can significantly enhance vehicle performance and optimize fuel efficiency. Emphasizing preventive maintenance not only extends the lifespan of the components, but also improves the overall driving experience. In conclusion, understanding the AF sensor's critical role is key in maintaining vehicle performance and compliance with emission standards. Diagnosing DTC P0135 requires a systematic approach, including initial verification, DTC checks, fuse inspections, and continuity tests. By effectively following the given troubleshooting steps, technicians can accurately pinpoint the source of the malfunction. Additionally, performing regular inspections and preventive maintenance helps mitigate the chances of future issues. Ultimately, ensuring that the systems are performing optimally is vital for fuel efficiency, engine performance, and environmental responsibility. A methodical approach to addressing DTC P0135 will lead to substantial improvements in vehicle functionality. Please like and subscribe to the channel. See you next time.